Well, I got Modserve working again using Visual Studio 2022, SQL Express Server 2022 as well. Default installation. The basic installation of both those tools is free, and I'm using the newest version of ModRSim, which is Modbust Simulator, so I can simulate a hardware device. And I was able to get the code working again, although it is now working in .NET 4.8. And here's the solution here. It's up on GitHub, and let's take a look. Over the years, I've added like some threading, better granularity, a little bit better documentation. The IEEE 754 conversions were from the beginning, and to take a look at the table is probably a good way to start. Whenever you want to build your data tables for this project, I used, for example, my SQL Express database feature, and here I just basically added a new table called history. Then I ran a query to be able to build this table called dbo.history, and let's just take a look at it so it's easier to understand what the query did. Basic text file, it's in the GitHub repository, and creates a table, gives me my registers. I have 96 registers, I believe, yep, and then I have a number of floats to be able to handle the quad precision IEEE 754 conversions, so that will show up in the database as well. That is the basic table structure. We'll use that to take a look at the rows and see what's in there after we start the server. So the code is worth taking a look at as well. We can take a look at the designer too, but let's start with the code. And again, it's a threaded model now. There's a basic try-catch style arrangement, and also when you quit the program, it simply stops the server so that you don't have redundant instances. I have ran it actually up to 3 or 10 instances, but it's not as stable. So I do a quit kind of and a stop the server kind of process to keep that stable. Basic counting is going on. Once you're in the actual main thread, you're starting to grab data from the Easy Modbus DLL. That Modbus client, once it's connected, will start grabbing the 96 registers, for example, and once they receive those, they do a little formatting and a little bit of converting to get the floats. The SQL connection string is your standard connection. I'll show you in the default connection string for the form designer. We don't have to look at the designer, but I'll show you in the product once we start it that the default connection string is pretty straightforward, but you can also use any connection string. I've used it to connect to Azure, and I've been able to run databases back and forth. I've seen that the granularity can stick to 1 sample a second, although we have the default of a sample every 5 seconds. That makes everything nice and lockstepped. You'll see a little bit of determinism issue in the rows, which I'll show you when you're at 1 sample per second, and that's simply because the fetch for the SQL row is not at the same deterministic level as the fetch for Modbus registers, which is to a hardware device, right? So from the hardware device to the software device, you will see a little bit of determinism sway, but it's pretty straightforward, and it's good enough for a good historian. Let's take a look at it. The way to run it is, first you got to get the simulator running. This is the freeware I found on the web. It's going to read the first 96 holding registers, so from 40000 to up to 96. It's going to read. What we'll do is we'll just change a few of them. Double click on a value and you can change something so you can simulate it. We'll just change a number of values in the first several registers so we know we'll see them in the rows. And that'll be listening on localhost, so 127.0.0.1 at port 502. Let's go ahead and start the server, and you'll see that the defaults are in place. Server is stopped, but the standard connection string is in there. This is the one for SQL Express 2022, so the GitHub repository with Modserve 10 in it has the defaults for the standard install. I finished all this, when I did the upgrade, I finished the entire install in like just a few minutes. You start the server will connect, and it'll give you the feedback. So now that the server is connected, we can go into the Object Explorer, down to that table again. Let's take a look at the data. So here's data coming in, 45 and 23. Let's double check that on the RSIM. We've got 12. Oh, well, it looks like we've got to go down some rows. It's probably just starting. Yeah, there it is. Every 5 seconds. I can hit a refresh on that, and there'll be a few more rows. So it's 12, 113, and that's what we've got right there in register 1 and 2. You get a basic timestamp. Here's where the determinism comes into play. As you can see, it's about every 5 seconds. It can occasionally sway because of the fetch mode of the SQL Server itself, right? So the SQL Server is pulling a row of all those registers, but it isn't necessarily pulling it at the exact same cached, timestamp of the hardware, right? So this is more along the lines of a cyclic grab of the data. Okay, I could set it up for change of value, but this seemed like a good way to just grab data when you want it. In the standard for XXX, Modbus registers you're going to find in most hardware, right? So that's kind of a way to deal with it as straightforward as you can. Again, it's just a simple historian. As you can see, it's pulling in the values. Let's go ahead and change a few values. Let's change it to 77, 78, something like that. And after 5 seconds, we'll get at least one row of that, and actually we've already got some. So there they are, and those are the changes. See how it changed even in between the registers. So it does grab the rows in lockstep. I've done a lot of stress testing on the threading, and it's looking pretty good. This is how the Modserve works. And if you have any questions, go ahead and shoot me a message. Thanks very much. I hope that helps.